In this tutorial, you'll learn how to set up and analyze a grinding mill simulation using the Tavares breakage model. This model captures the various body breakage mechanisms that occur during particle collision. Start by setting the units for the simulation. Next, define two bulk materials. Name the first one as ore, and the second one steel. Only the ore material is expected to break. Define the bulk material's properties and interactions. Next, add a single sphere particle to the ore material. Set the particle's radius, the contact radius, and the particle size distribution. Repeat the process for the steel material. Input a physical radius of 25 mm. Select the normal size distribution for the steel material with the following parameters. Finally, click on Properties and make sure the Auto Calculation box is selected. Next, add an equipment material and name it rubber. Define the equipment material properties and interactions. The next step is to define the mill geometry for the simulation. Set the units to millimeters, check the Merge Sections option, and leave all the mesh setting as default. Next, add a linear rotation kinematic to the mill and set the required parameters. To generate particles in your simulation, you need to create a particle factory geometry. For this tutorial, add a cylinder geometry and set its type to virtual. Select the transform subsection and set the X rotation to 90 degrees. Add two dynamic factories to the cylinder and name them accordingly. Next, you have to define the factory's particle creation values. Select target mass and set the rate value. Ensure the correct material is selected from the material parameters. Add a particle velocity in the Z direction. This will help with particle creation and speed up your simulation runtime. Repeat the process for the steel factory. All factories' values are provided in the tutorial documentation. The next step is to define the physics for the model. For the particle-to-particle interaction, select the Tavares breakage model. Configure the model for the ore particle as shown. Each particle has a specific fracture energy, which is assigned based on its size, mean value, and standard deviation. Please note that the particle-to-geometry interaction and the particle body force are both populated by default with the breakage model. Next, move to the Environment tab and enable periodic boundaries in the Y direction. This will ensure that particles stay in the domain. Next, move to the simulator. Set the simulation parameters, including the time step, simulation time, and the target save interval. Then select your simulator engine. If using a CPU solver, you must set the cell size. We're using the GPU solver as it is typically faster. However, ensure that you have a compatible GPU card first. Once your simulation is complete, move to the Analyst. The display section in the Analyst tree is used to configure how the different elements in the simulation appear. Uncheck the Display Factory box to improve the visualization of the particles. Color the ore particles according to their diameter. Assign colors to represent the minimum, medium, and maximum particle diameter values. Check the Auto Update box. This allows the diameter values to be updated according to which time step is being viewed. Next, add a legend. Set a uniform color to the steel particles. Next, create a histogram for the ore particle size distribution. This represents the material particle size distribution at the end of the simulation. You can also use the breakage post-processing tool. All the breakable particles in this simulation are being replaced by sets of families of fragments with different size distributions, replicating real-life scenarios. Here, the particles can be analyzed to calculate the corresponding distribution of fines that may have been generated below the minimum specified particle size. This method extends the size distribution without the need to create finer particles within the EDEM simulation. Once the script finishes running, 2 files containing data on the particle size distribution will be saved in the specified folder.